Section 7.10, solve the absolute value equation. Number one, isolate absolute value part. And a little note on that, if the absolute value part is equal to a negative, then your answer is going to be no solution. An example of that is if you've got the absolute value of 5x plus 3 equaling negative 7, equaling a negative number, then you're going to have an answer that's no solution. One of the main concepts behind everything that we're going to do with the absolute value equations has to do with this point here. If you've got an absolute value of 5, that equals 5. And the absolute value of negative 5 also equals negative 5. And then you're given something like this where you've got the absolute value of x is equal to 5. Then that means that x could be either 5 or negative 5. Either that or that. So on our first example, the absolute value of x equals 6. Then what that means is the only two things that x could be is 6 or negative 6. And that's not the type of example that you'll typically see. But for our first example here, actually you'll see something more like this. The absolute value of 5x plus 2 equals 6. And if you forget about the 5x plus 2 part and the way that looks, the thing inside, the absolute value of the thing inside is equal to 6. So what that means is that this could be 6 or the thing inside could be negative 6. And then we just work those out algebraically and subtract 2. Divide 5. Okay, so we've got one solution so far. Next one, just going to do the same thing. Subtract 2. (5x) equals negative 8. Divide 5 on both sides. Okay, so we end up with x equals negative 8/5 there. Make sure you do reduce these if possible. 4/5 doesn't reduce, negative 8/5 doesn't reduce. And you'll notice that we've got two answers there, so they'll give you an option here that you'll need to select. So we'll select two solutions, and then you'll put both of your answers in there separated by a comma. So you'll have a box, and you'll put in 4/5, comma, negative 8/5. Next up, number 2, absolute value of 2x plus 5 minus 1 equals 0. So on the first slide, I mentioned that you'll want to get the absolute value part by itself. Get absolute value by itself. So in this case, we do have something that we can get rid of that isn't a part of the absolute value. This would negative 1. So we'll start off by adding 1 to both sides. Absolute value of 2x plus 5 equals 1. And then we're in a situation just like the first example that we looked at. We've got some absolute value, and just keep in mind, if you had the absolute value of x equals 1, then x would be either 1 or negative 1. This thing inside has to be 1 or negative 1. So same is true here. This thing inside here is either 1 or it's negative 1. Okay, and then once you've got that, we just work that out. Subtract 5 from both sides. 2x equals negative 4. And then divide 2. X equals negative 2. And then x equals negative 3. So again, two answers. You want to enter those in with a common between -2, -3. Number 3, 2 times the absolute value of x plus 8 plus 10 equals 6. So again, we're going to start off getting the absolute value by itself. So a few things we'll do there. Start off by subtracting 10. That gets rid of that part. Then we've got the 2 and then the absolute value of x plus 8. Be careful you don't distribute that. It's not exactly what you would do with an absolute value equation. We just want to get rid of everything besides the absolute value part. So 6 minus 10 is -4. And then, since the absolute value and 2 are multiplying, we'll divide the 2 to get rid of it. And then we're left with the absolute value of x plus 8 equals -2. And then from there, it's just like the first two examples. We've got this thing inside. Absolute value of it equals -2. You will want to note that if the absolute value equals a negative, we don't need to work any further. We just say no solution. And that's once you've got the absolute value all by itself. If it's got other things with it, you'll want to get rid of those things and then make your determination whether or not it's no solution. But at this point, we've got the absolute value by itself. It's equal to a negative, so we can say that confidently. Number 4, absolute value of 4x minus 5 equals -3. This is an example of what we just got done talking about. You've got an absolute value equal to a negative. There's nothing with the absolute value that we need to get rid of. So we can just say no solution. And this is one of those nice ones that you don't have to do any work on. As long as you recognize that, you can just click no solution and then move on. Number 5, the absolute value of -6x minus 7 equals 0. So if we had something like absolute value of x is equal to 0, then you'd say, well, x has to be 0. There's no other options. So this inside is equal to 0. And we wouldn't say equal to 0 and equal to -0 because -0 isn't a thing that we say. So -6x minus 7 equals 0 is the only way that we can write that. We'll work this out and we'll have one less solution than we typically have. So start off by adding 7. -6x on the left is equal to 7. Divide, make sure you divide by -6. That gets rid of that. And then we've got x equals 7 over -6. And you will, this is the way the software wants you to put the answers in, you will want to move that minus up, move it up to the 7 or move it out in front of that fraction line. But move it up from the bottom. And when you've got your no solution option, 1 solution, 2 solution. In this case, we only have 1 solution, so you put in that -7/6 in there. Number 6, the absolute value of -2x plus 3 equals -4x plus 2. In this case, if you've got two absolute values that are equal, then the things inside, you know, if you can imagine the absolute value of 5 and then the absolute value of 5, that would be true, of course. Absolute value of 5 is equal to the absolute value of 5. Another thing that's also true is the absolute value of 5 is equal to the absolute value of -5, because this is in reality 5 and this is also in reality 5. So we can say that they're equal. So what that tells us is that either the numbers are exactly the same if this is true. Either it's a 5 inside and a 5 inside, or you've got two numbers that are the opposite. You've got 5 and you've got -5. So either, if two absolute values are equal, either the inside is the same, equal, or they're the opposite of each other. So when we work this particular problem out, and I'll separate this out, it means that negative 2x plus 3, the thing inside the first absolute value, is equal to negative 4x plus 2, the thing in the other absolute value. Or, let me erase some of this. Negative 2x plus 3 is equal to the opposite of negative 4x plus 2. Hopefully you can see that. So it's either equal to exactly the same thing or it's equal to an opposite, which I show that by putting the minus out in front of it with parentheses. Another way you can write that is just to change the signs of both the negative 4x and the 2. And you can write this as negative 2x plus 3 is equal to positive 4x, which is the opposite of that one. And then the 2, the opposite of it, is negative 2. So it's either exactly the same or opposites. So you leave the first one exactly as it is and then do opposite on the second one. And then we'll work out both of those. Subtract 3. Actually, let's go back. Anytime you've got x's on both sides, probably what you might want to do at the start is just to get the x's on the same side. So we've got negative 4x on the right, negative 2x on the left. It doesn't matter which way you move the x's. I'm going to go ahead and add 4x. So we've now got 2x plus 3 on the left equal to 2. Subtract 3. 2x equals negative 1, and then divide 2. That gets our x by itself. X equals negative 1/2. And then over to the other equation. Again, we want to get the x's on the same side. We'll move the 4x again. 4x minus 4x gets rid of that. So we've got negative 6x plus 3 equals negative 2. Subtract 3. Negative 6x equals negative 5, and then divide negative 6. And x equals, we've got negative 5 over negative 6, so the negative on top and the negative on bottom cancel each other out, and we end up with a positive answer. So we've got two answers here, negative 1/2 and 5/6. Here, roughly the same thing. Absolute value of 5x over 2 plus 3 equals the absolute value of x over 4 plus 5. So either the things inside are exactly the same or they're opposites. So 5x over 2 plus 3 is equal to x over 4 plus 5. They're exactly the same. Or 5x over 2 plus 3 is equal to the opposite. So I'm going to change both signs of the other two things. So negative x over 4 minus 5. All right, and then one thing I want to mention here, anytime you've got an equation with fractions, I'll erase this in just a second, but equations with fractions, there's a few different ways that you can approach that, but the way that I typically do it is to figure out what the common denominator is and then multiply that by the top numbers. So we're going to multiply the tops by a common denominator. And what that'll do is that'll get rid of all our fractions, and it should be pretty simple to solve from there. Hopefully you guys can look at the denominators that we've got here, 2 and 4, and figure out what they both go into. 2 is too small because, of course, 4 doesn't go into 2, but both of them can go into 4. So if we multiply 4 by all of the tops, then we should be able to get rid of the fraction. So I'm going to go ahead and do that. Multiply 4 here. Let's do that in red. Multiply 4, multiply 4, multiply 4, multiply 4. Same denominators on the right side, so multiply 4, multiply 4, multiply 4, multiply 4. And if you've got a 4 on top and then some number on the bottom, you can just divide those. So the 4 divided by 2, that just turns into 2. On the right side of the equal sign, the 4 on bottom and the 4 on top just cancel each other out. Going over to the other equations over here, we've got the 4 on top, 2 on bottom. That reduces to 2, 4 divided by 2. And then on the other side of the equals, 4 on top, 4 on bottom. Those both cancel. Okay, and if we write what we've got left, so you've got this 5x times 2. We've got this 3 times 4. On the right side, both of those 4's have canceled, so we've only got x plus 5 times 4, which is 20. Should be pretty simple to work out. Or here we've got the 5x times 2 again, plus 12. Equals, the 4's have canceled out, but we've got negative in front of the x, minus 20. Okay, so we want to get the x's on the same side here, so subtract x. And we've got 9x plus 12 equals 20. Subtract 12, and we've got the 9x by itself, equal to 8. Divide 9, and x equals 8 over 9. Okay, on the right side over there, we want to get the x's on the same side, so I'm going to add x. We got 11x plus 12 equals negative 20. Subtract 12. 11x equals negative 32. Divide 11, and we've got x equals negative 32 over 11. Again, make sure anytime you've got fractions at the end that you reduce those. Don't turn them into decimals. Unless your equation starts with decimals, don't put decimals in as an answer, just a reduced fraction. 32 and 11 don't have anything that we can use to reduce it, so 2 answers for that one. Number 8, they're going to ask you about standard form solution. And so all we're going to do is we're just going to get the absolute value by itself, and then we'll make some determination whether or not it has a standard form solution. So we'll subtract 6. Zero minus 6 is negative 6. And then you might divide by 2. We'll get the absolute value by itself. And then we've got the absolute value of y plus 1 is equal to negative 3. Okay, so anytime you've got an absolute value equal to a negative number, then we'll just click no. Empty set, no solution. And last up, just a couple things to note. absolute value and set notation symbols you'll find in the keypad. That's something that is a button that you'll see near the problem that you're given. So on that same screen that you're looking at, you'll see keypad. It's got a lot of different things in there, but you'll look for something that looks like absolute value with a box in the middle. That's what you'll want to select, and then you'll enter what goes in the box if you need it. And if you're asked to put your answer in set notation, find the squiggly parentheses. That's what set notation is. It's like regular parentheses, but squiggly, of course. And enter your answers in them.